Welcome to Module 3, Lesson 12, where we are going to talk about properties of inequalities. Okay, now these inequalities, while maybe they sound confusing to some of you, or maybe some of you have some history with them, they are not all that confusing, okay, because they are really equations with a twist, okay? So let's take a look at some examples. And again, this lesson 12 is not going to get into the solving of inequalities quite yet. It's just going to talk about the properties of inequalities, okay, to get you to understand the let's say the theory, for example, justify those properties, okay? And okay, so let me go ahead and talk a little bit about this. So we might have an equation, and we know our equations right now. Okay, and here's an example of an equation. Okay, an equation is very simply, connotated by an equal sign. Okay, so in this case, we are saying x plus 1 equals 5. Okay. And of course, how we solve for that is we know x plus 1 and then plus negative 1, okay, just the additive inverse, and then 5 minus 1, and then we have x equals 4, of course. And that is our solution, okay? So we go from an equation, and then we can solve that equation. Okay, for now we are solving equations. In the future, I'm not sure this year, but at least next year you'll be doing things like this, equations that actually have no solution, okay, and that is the case. But for now we have equations which lead to solutions. Now the only difference here, if we go from equation to inequality, this problem might be written like this: x plus 1 is greater than 5. Okay, x plus 1 is greater than 5. Okay, so this is an inequality. It means that it is not equal any longer, but it is unequal. Okay, it's unequal. So we have written an inequality. Okay, so this statement here is an inequality, and you can see how similar it is to this, which is an equation. Okay, and it's an equation because there is an equal sign in the middle. Okay, so that's what makes it an equation. With an inequality, it's an inequality because there is either a less than sign, as you can see here. Okay, and we always talk in terms of the the variable side. Okay, so x plus 1 is less than 5. Okay, but this could also be x plus 1 is, I'm sorry, this was greater than 5 here. Sorry, I must have said that before. X plus 1 is greater than 5. We could also say x plus 1 is less than 5. This is also an example of an inequality. And actually there are a couple of more. We could also say, and we'll work more and more on this as we go through, so we'll have examples. I don't expect you to know every single thing right now, but some of you may know this already. We could also have x plus 1 is greater than and equal to 5. This is still an inequality, okay? But if you notice here now, you have this little line underneath the greater than sign, okay, which says greater than or equal to. So in the same vein, we could also have x plus 1 is less than or equal to 5, okay? All right, so there we go. These are all examples of inequalities, okay, inequalities, because there will be cases, for example, well, let's say you want to earn a certain amount of money, okay, at least a certain amount of money, and you are going to babysit to earn that money. You might want to know how many days you have to babysit for to reach that goal. Okay, to reach that goal, you could use an inequality for that. So, you know, X times, let's say you made $20 a babysitting session. So X times 20, or 20X, is greater than or equal to 300, for example. Okay, 300. So you at least want to have 300, but you could also have more, but you surely don't want less. And I'm not sure if that sounds confusing quite yet, but there will be opportunities to use inequalities in context. Okay, so these are what inequalities are. This lesson 12 is only going to talk about some properties. We're not going to see, I don't think we'll be seeing, oh, maybe we will. Okay, I'm not quite sure if we're going to actually see this format come up. Okay, so let's get started. Let's look at example 1 in your binder. Now there are a couple of sprints that go along with this lesson, and they are linear equations. You know, for example, x plus 1 equals 5, and of that nature. That I will not do. They're meant to do in class. First thing, I will save those for the end of this lesson, in case there are some of you who are not really quite interested. Okay, but those sprint sheets you will find at the end of lesson 12. Let me make sure. I'm going to turn there, and yes, they are there. Okay. Okay, so here with this this example 1, what I'm going to do is I'm going to create a die, okay, out of this template I have, and that's what this this lesson is meant to be. It's meant to be a lesson where you go through different stations, as you can see here. I think there are, like, I don't know, 4 or 5 different stations, and you are going to roll these dice, okay, these paper dice, and then come up with the die. You can see die 1. You're going to roll die 1, then you're going to roll die 2. Okay, and you're going to have your 2 integers, okay, from those die, and actually I would just tell you right now, those die, the integers they have on them, they have 5, let's see, one of them has 5, -3, 4, 2, -6, and -1, okay, and then another die has -5, 6, as you can see. It looks like there's opposites here, huh? -2, 3, -4, and 1. Okay, so there's we have looks like we have additive inverses of all these numbers, as you see. Okay, so that would be, you know, there's die 1, there's die 2, and I'll be quote unquote rolling those for you, and so we'll all be doing it the same way. But in the class, you would be moving around in stations, okay, 4 different groups, okay? So, yeah, so what you're going to do is you're going to roll that, then the inequality you're going to create, you're going to use the symbol that, that goes along with that inequality. So, as you can see, die 1 here is negative, we rolled a -3, or this is the sample, and then die 2 was a 5, therefore we're going to put this symbol here because we know the alligator eats the bigger number. Okay, so it's going to eat the 5. All right, so in this case we would see that, you know, -3 is less than 5. Okay. All right, now the this operation part right here is just is assigned to you. Okay, it's assigned. So what they want you to do then is to add 2 to these 2, okay, right here. Okay, add 2 to these 2 there. All right, so then you come up with this this new inequality here, and it is, as we can see, -3 plus 2 is less than 5 plus 2. So you can see the 2 has been added to both sides. That's what this operation is. And we'll do a few examples. And the only reason we're doing this is we are trying to set up inequalities just randomly. Okay. Now the part I wanted to talk to you about, just may need some explanation, is this here. Is the inequality symbol preserved or reversed? Okay. And let me explain that to you to your right here. Let's go ahead and take some notes right in this section up here underneath example 1. So right over here. So it says, so to preserve the inequality symbol right here, okay, I'm working right here, just write this in, okay, means the inequality symbol stays the same. Okay, and let's look at this example and see what we're talking about here. Okay, it means the inequality symbol stays the same. So what's going to happen after you solve this inequality, just like you would solve a any equation, you can see right here. See what we've done? We've actually taken away the we actually have -1, so -3 plus 2 is -1, 5 plus 2 is 7. So the inequality here is, we say, is preserved. Okay, it is preserved because it is true. This is a true statement. -1 is less than -7. Okay, so this checks out. So in this case, the inequality symbol is preserved, so it stays the same. Okay, so we continue to have that less than sign right there as we move left to right. Try to always move left to right as we read. Okay, so -1 is less than 7. Okay, and it is preserved. Okay, so that's this example here. But we'll go ahead and do a few of these together. Oh, actually, I guess we're doing them all together because you can't do them because you're not in class and you don't have these little die in front of you. So yeah, we'll go ahead and do these together. So, but the next one is reverses the inequality symbol. So what that means is that if, for example, we got down to a point where we had something like this: -1 is greater than 3, after we've solved our inequality. Okay, well, this is not true. Okay, so this is not true. So this would be a case where the inequality symbol would be reversed. Okay, would be reversed. It'd have to be reversed. We'd have to actually change this symbol to actually reflect the reality of it. I don't mean that's not an X there. That was just a kind of symbol. But yeah, so we'd have to reverse it. See, we started with it. We solved the inequality. It looked like that. The truth is, it's not true. Okay, so we'd have to reverse it to make it true. Okay, so in this case, we can write down here, means the inequality symbol switches switches. Okay, so it's either going to switch from greater than to less than, or less than to greater than, or less than or equal to greater than and equal to. Okay, so we're going to work through this together. So I'll be able to clarify along the way. Okay, again, so we are building inequalities here. Okay, so now we are going to start and with with station 1, and what I'm planning on doing is to go ahead and do a few of these with you. There are 4 different stations, like I said, and as you can see, you can see them in your binder, but I'll just show you here. So you have, now we're looking at multiply by -1 throughout here in the station 2. Seems to be the theme there. Okay, all multiplied by -1. Here's station 3. We have multiply by 1/2. We have multiply by 2. We have divide by 1/2. Okay, and as you can see, divide by 2 and multiply by 1/2, same exact thing. Okay, but just to show the operations. Okay, different operations. And let's see, in station 4, just more multiply and divide, but now by negative numbers. Okay. All right. So let's go back and let's go ahead and start. Start right here. This is station 1, and so let me just show you what these dice look like here. Just took a photo of the dice. There they are. They, as you can see, regular old paper dice, which took me too long to make. In the future, I think I'll just go ahead and make them out of blank dice and do it that way. But anyway, yeah, there they are. I'm going to roll them one at a time, okay, and then we will record our numbers, and we'll perform our inequalities, okay. Now again, with the inequalities we're doing here, as you can see, they're all numbers, okay? So we are actually not using any variables at this point, okay? Just trying to take a look at using these different symbols, okay? The less than symbols and greater than symbols, okay? All right, so with no further ado, let me go ahead. I'm going to use this. I'm rolling die 1, -5. Okay, rolling die 2, 4. Okay, you can see how that works. And now what we will do is we go ahead and we look at it. So you're going to look at it. Which way would the inequality symbol go? It would go this way, of course, because -5 is less than 4. Okay, and so now we're going to add 3 to both of those. Okay, just like we added 2 to both of those here. All right, so then we're going to go -5 plus -3 is less than or equal, no, sorry, no, I didn't mean to do that, just less than, this is not a less than or equal to sign, sorry, less than 4 plus -3, okay, 4 plus -3. So let's go ahead and do that, and if we go ahead and solve here, we got -5 plus -3, of course, is -8. And we have our less than sign, and then we have 4 plus a -3 is actually a +1. Okay, so we have that's our statement right now. Is the inequality symbol been preserved or reversed? And of course, it has been preserved because that is a correct statement right here. Okay, all right. So. Why don't we do one more together? We've done an add. We've done an adding a positive number, adding a negative number. And again, how is that different than subtracting? Well, here it is right here, just the way I write it. Okay, it's a plus -3 instead of -3. Okay, but let's go ahead and do this one, which is subtract 2. Okay, so let's go ahead and do this one. So what I have to do, of course, I need to roll my die 1. And I have rolled a 6, roll die 2, and I've rolled a 5. Okay, so in this case, of course, our inequality symbol is going to be greater than, because 6 is greater than 5. And now I'm going to subtract 2 from both sides of the inequality. So I have 6 minus 2 is greater than 5 minus 2. And if I do that, then that says 4 is greater than 3, which of course is correct. Our inequality symbol, once again, is preserved. And you might be seeing a pattern here, preserved, preserved, preserved. Might or might not. And you might be wondering, when will the inequality symbol be reversed? Barrel, barrel, barrel. Well, I guess we shall see. So, okay, so what I'm going to do now is that there are two more, right? 2 more here. 2 more. So I'm going to go ahead and pause and roll these dice and then put the numbers in and have you do them yourselves, okay? Okay, so here are my 2 pairs of numbers that I rolled. I rolled 3 and -3 here, and then I rolled -2 and -1. You do the rest, and then come on back and check your answers. Okay, so here we go. As you can see, I've completed these, and anything you might have gotten wrong, just go ahead and correct now. You can pause this if you'd like to make those corrections. But yeah, see, we have 3 is greater than -3. This one here you might have been confused by, but don't be, hopefully not, because the -1 is actually greater than -2, or -2 is less than -1. All right, then this asked me to subtract 1, okay, and hopefully you did that correctly, because if I subtract a negative 1. I'm sorry, I meant to subtract a negative 1. Remember, when you subtract a negative, it's the same as adding, okay? So I subtracted a negative 1 from this side. I ended up with 4, because 3 minus a negative 1, 3 plus 1 is 4, and then negative 3 minus a negative 1, or negative 3 plus 1 is a negative 2. And of course that symbol was preserved, inequality symbol was preserved. Here I'm adding 1 to both sides, end up with negative 1 as being less than 0, and that is true, and preserved again. Okay, so here's station 2. It looks like our question has been answered here, because as you notice already, that the inequality symbol has been reversed in this first one. But let's take a look at it. So die 1, a negative 3 was rolled. Die 2, a 4. Inequality was written, okay, because negative 3 is less than 4. Now you're going to multiply by a negative 1. And you can imagine, well, you know probably, multiplying a positive by a negative is going to get you a negative. But if you multiply that negative by a negative, you're going to get a positive. So right away we can see that this symbol is going to be reversed. But let's take a look at how it all panned out. So here we go. Negative 1 times negative 3. It's actually 3. Negative 1 times 4 is negative 4. And you can see that that does not work, because right here this is a... that does not work. Negative 3 is not less than... 3 is not less than negative 4. Therefore we had to reverse our inequality symbol. Okay? Alright, so I guess you can probably see these are all multiplied by negative 1. Therefore, we might see some trends or patterns. Okay, so again, I am going to roll some dice and put the numbers in their places, come back and show you, and then have you do the work and come back and check it. Okay, well, here are your pairs of numbers. Okay, so go ahead and create your, write down inequality. Actually, multiplying 1 goes throughout. So multiply each side of that inequality by 1, and then determine whether we have a preserved inequality symbol or a reverse inequality symbol. Okay, so go ahead and come on back and check your answers. Well, if you did everything correctly, and I did everything correctly, you would have noticed what I noticed, that this multiplying by negative 1 reversed every single situation, okay? Whereas we had 3 less than 4, we ended up actually with negative 3 being greater than negative 4, okay? We had 6 greater than negative 1. Turned out that negative 6 is less than 1. Negative 4 is being less than 4, but 5 is greater than negative 4. Negative 4 less than 5, but 4 is greater than negative 5. Okay, so the multiplying by negative 1 in all of these situations reversed everything. Okay, and a good thing to look at, a good thing to know. Okay, let's move on to station. That's the end of that station. Actually, we had a little. Okay, so if you examine the results here, I don't think we didn't do this for the first one either. I'm sorry, but examine the results, make a statement about what you noticed, and justify it with evidence. Well, if you wrote something to the to the effect what I just said, multiplying by negative 1 by a negative 1 seemed to reverse all inequalities. And then then you could just cite one of these examples up here as your evidence. Okay. All right. So station 3. Let's take a look here. Station 3. let's look at the example here. Now we are multiplying by 1/2. Actually, we're doing a number of different things here, as you can see, which should be fun. Lots of fun. All positive, though. I see all positive numbers. Multiplying by 1/2, multiplying by 2, dividing by 2, dividing by 1/2, and multiplying by 3. Okay, so that should be a lot of fun. Anyway, let's go ahead and look what happened with this scenario, the first scenario they gave us. So we had -2 being greater than -4, of course, which is true. Now, if you go ahead and multiply by 1/2, and again, noticing that 1/2 is a positive 1/2, okay? You notice what happens here. -2 times 1/2 is actually -1. -4 times 1/2 is -2, and therefore the inequality symbol has been preserved, okay, because -1 is indeed greater than -2. Okay, so in this case, multiplying two negative numbers by this positive 1/2 maintains or preserves the inequality. Okay, all right, so again, you guys know how to do this. You've been doing this a long time now, multiplying by fractional numbers, dividing by 1/2. Remember what you do when you divide by 1/2, okay? So don't let that one fool you. All right, so go ahead and complete these. And oh, actually, let me go ahead and roll some dice and come on back and give you those numbers. Alrighty, so here are your numbers. Go ahead and do your best work and come on back and check that work. Okay, so here we are, station 3. Wrote out all of our inequalities first. Okay, right here, greater than, less than, and less than. Okay, so let's see what happened. Oops, what do we notice here? All were preserved, and hopefully you guys had all of those as preserved as well. Because here when I multiply, these are all positives now, remember, so there might be some sort of connection there. 6 times 2 gave us 12. -6 times 2 gave us -12, and that was preserved. So here we had 1 was greater than -6. We ended up with 1/2 being greater than -3. Okay, so when we divide by 2, and the way I wrote my division here, I just put 1 divided by 2, -6 divided by 2, and I just put them, I used fractions to help me out, okay? And 1/2 just remains the same, and then -6 over 2 is actually -3, okay? And hopefully you guys are working this out nice and smoothly. Now dividing by 1/2, as we know, is the same as multiplying by 2, because we multiply by the reciprocal of the fraction we are dividing by, okay, the divisor. All right, and therefore -4 times 2, or 2 over 1, of course, is -8. 2 times 2 over 1, or 2, is 4. Okay, and again, that is preserved. All right, and again, dividing by 1/2, just this whole fraction concept, I just want to keep pounding away at. You divide by 1/2, you're asking yourselves, well, how many halves are there in 2? And there are 4. There are 4 halves in 2 wholes. How many halves are there in -4? Well, there are -8. Okay. Truth is, there's 8 halves, but negatives, of course. All right, and down here we started out with our -5 being less than 4, and that turned out to be, we multiplied all of that, both sides by 3, a -15 is still less than 12. So everything was preserved. So if we're going to make a statement about what we notice here, we notice that, just generally, that when multiplying or dividing by a positive integer, our inequality is preserved. And then again, just to serve as evidence, we could use the evidence from one of the problems from above. All right, here we are at station 4. We're blowing through this, 29 minutes in. And hopefully you're getting this idea, feeling more comfortable with this idea of inequalities. Again, we haven't applied any type of variable unknown to this yet, but we're just trying to get some properties of these inequalities and some of the things that we're noticing, such as multiplying by positive integers, multiplying by negative integers, and what that does to the inequality, reverses it, okay? So here we go. Station 4. Now, as you see, we have multiplying by negatives and dividing by negatives, okay? Seems to be our theme here. So let's look at the first one. Die 1 was 3, die 2 negative 2. Therefore, we know 3 is greater than negative 2. And if we apply this, we multiply by negative 2. We turn that into negative 6 and turn that into 4. And of course, as we have seen in the past, multiplying by that negative is going to reverse the inequality symbol. Okay? So let me go ahead and roll some dice, get back here with some numbers for you, and then you can get going. Okay, well here are your new batch of numbers. All right, so go ahead, write in your inequalities, and do the operation that they ask, and write your new inequality, and then let us know if they are preserved or reversed, those inequality symbols. You might have an idea of how this is all going to go already. So yeah, come on back after you're done and check your answers. Okay, so as you may have predicted, in all of my cases at least, hopefully yours as well, since we are using the same numbers, multiplying by the negative 3, dividing by negative 2, dividing by negative 1/2, multiplying by a negative 1/2, all yielded the same reversal answer. Okay, they all had to be reversed. This first one, negative 2 is greater than negative 3, but when multiplied by another negative 3, 6 is actually less than 9. Reverse. Negative 4 is less than positive 2, but when both are divided by 2 or multiplied by 1/2, ends up to be 2 is actually greater than negative 1. 5 is less than negative 1, but after applying the division by a negative 1/2, which is also multiplying by 2, okay, it's reciprocal. 10 is then greater than 2, reversal. Negative 2 is less than 5, but when both are multiplied by negative 1/2, we end up with 1 being, actually, one over here, 1 being greater than negative 5/2 or negative 2.5. Okay? So if we examine our results and make a statement, we could say, as noticed earlier, multiplying or dividing by a negative integer or rational number, in this case, I guess, or a rational number, reverses the inequality. Okay, and these are good things to remember, and again, this is all just setting you up for what we'll be doing coming up in future lessons. Okay, so for this last exercise, this is something you're going to be doing on your own. Okay, and I can't quite tell how well you do with it from here, but I'm going to trust that you do complete it and complete it well. And if you have any questions, just give me a call. I will actually come back. Well, I'll do one together just so we can explain this exercise a little more clearly. But I'll come back and present you with all of the examples that I did. Because what you're going to do here is you're going to complete the chart using the given inequality. Okay, so you're given these inequalities here. These are all going to be given to you. Okay, so you have those to use. But the idea is to create an operation and a new inequality which preserves the inequality symbol. Okay, so you're going to choose a number to apply to both sides of the inequality to preserve that inequality symbol. And then with that same inequality, you're going to go ahead and create a new inequality which reverses the inequality. Okay, reverses. So, for example, so if we have 2 is less than 5, all right. Let's say we add 4 to both sides. Now we're doing that, and I'm doing that because I know one of the things I noticed in the last problems is that every time we added a similar number to both sides, we preserved the inequality. So if I add 4, that would make it 2 plus 4 is less than 5 plus 4, and that would mean 6 is less than 9, which is correct. Okay, so that is right. So I have preserved the inequality in this case. Now I know if I want to reverse the inequality here, and again I'm using the same one, 2 is less than 5. Okay, I know what I learned from this lesson is that I can multiply both sides by a negative, so I'll choose negative 4 this time. Okay, so if I multiply each side by negative 4, I end up with, so 2 times negative 4 is less than 5 times negative 4, and so that's negative 8 is less than negative 20, which of course is incorrect. Okay, so that's a big old no there. So I'd have to make that negative 8 is greater than negative 20. Okay, and in this case it is reversed. All right. So again, for the inequalities given, go ahead and apply, preserve in this column here. Okay, in this column you want to preserve the inequality. Adding is a good one. Subtracting is another good one. Okay, on this side, or you can over here you can multiply by a positive number as well to preserve the inequality. But when you're going to reverse, remember multiplying by negatives or dividing by negatives is going to reverse. Okay, so you're going to do that. All right. The explanation, throw it in there if you want, every other one, just to get some practice with that. Okay, so go ahead and finish those. Come on back. I'll show you some examples I did. Okay, so here are some answers that I came up with, and you might have, of course. I mean, if you have the same exact thing, I'd be very, very surprised. But I'll go over them one at a time just to show you what happened, how I preserved, and how I reversed. I chose in this first one here to subtract 3. Okay, subtract 3 from both sides. All right, so when I subtracted 3, negative 4 is greater than negative 6, became negative 7 is greater than negative 9, which is correct. And so that is preserved. The inequality symbol remains correct. Now on this side, I went ahead, and you can tell what I did. I divided by a negative 2. Okay, divided by negative 2, so negative 4 divided by negative 2 is actually 2. Okay, and negative 6 divided by negative 2 is 3. So 2 is not greater than 3. So we had to reverse. That would correctly look like this. 2 is less than 3. Okay, so it needs to be reversed. All right. Let's see the next one here. The negative 1 is less than or equal to 2. Here they've used that less than or equal to sign, which means that it can be true by either this left side being less than or equal to the right side. Okay, no equal to comes into play right here. It might have for you though, whatever you might have plugged in or whatever you tried to do. Not plug in, but whatever you tried to apply. But in my case here, what I did is I multiplied both sides by 3, as you can see here. Okay, so negative 1 times 3 is negative 3, and it is still less than or equal to the 6 that I got by multiplying 2 times 3. So it is preserved. And again, I've multiplied here by a positive number. Okay, multiplied by a positive on this side. To reverse, I went ahead and I multiplied by that negative 1. And we saw what havoc negative 1 can wreak and early on. And yeah, so now the negative 1 times negative 1 is 1. Okay, and now the 2, my original 2 times the negative 1 is negative 2. So no longer is my inequality correct, because 1 is not less than or equal to negative 2. It's actually greater than, and I'd have to write that like this, greater than or equal to negative 2. So this is how I reversed, and I reversed, of course, by multiplying by a negative integer. Okay, and the last problem here, to preserve, I added 5, as you can see right here, added 5 to both sides. I had to put this 1 on 2 lines here, didn't have a lot of room. And when I did do that, I added 5 to both sides. I got it solved out to 0 is less than 1, which it is. Preserve. And of course, I went ahead and decided to multiply by a negative 1/2. Negative 1/2. Both sides, multiply them both by negative 1/2, because I know what happens when I multiply both sides by a negative rational number. So, yeah, so I went ahead and then I got, so negative 1/2 times 5 is actually a positive 2.5. Over here I had negative 1/2 times a negative 4 is a positive 2, which is not correct. It's not correct that 2.5 is not less than 2. Okay, it actually needs to be written that 2 1/2, or 5 over 2, is greater than 2. Okay, and that was how I did my reversal. Now, yours, of course, were most likely different than mine, but hopefully you've worked it out correctly. If you haven't, go back and practice a little bit. If you need any further help, just give me a call, of course. All right, so if you take out your your lesson summary sheet, we can fill in. We have a couple of blank lines here to fill in. And go ahead and read this together and then fill in those blank lines. So firstly, when both sides, reading from right here, when both sides of an inequality are added or subtracted by a number, the inequality symbol stays the same. And the inequality symbol is said to be, probably know this already, preserved. If you preserve something, you keep it. Okay? Preserved. All right? Again, added, subtracted by a number, inequality symbol stays the same. Okay? It is preserved. Now, when both sides of an inequality are multiplied or divided by a positive number, okay, the inequality symbol stays the same again. And again, the inequality symbol is said to be preserved. Okay, preserved. All right, again, that is multiplied and divided by a positive number. Stays the same, or preserved. Now, when both sides of an inequality are multiplied or divided by a negative number, the inequality symbol switches. Okay, so the inequality symbol is reversed. Okay, it is reversed. Right, inequality symbol switches when you multiply or divide both sides of an inequality by a negative number. Negative number means, we look at negatives. Negative means opposite of, so it makes sense that it would be reversed. Inequality symbol would be reversed. Okay, so those are the 3 properties that we wanted to get across in this lesson 12. go ahead and get your exit ticket done and your problem sets. Any questions, just give me a call, and look forward to seeing you again in lesson 13, where we will continue our study of inequalities.